Hello and welcome back to my Kubernetes series. In the last two videos we built a Postfix container and went through the deployment and config maps required to get the application up and running. In this video we will focus on setting up the database we need to manage virtual users, the mail settings required to use their mail service provider's relays such as username and password, and much more. So let us access the database and create the tables we need, and then we will get Postfix deployed. So let's switch over to the terminal and find the command we need to access our database. For that we enter our KDS setup folder. 8 was the database. We have our access db text, which we copy and paste, and we access our database. Once logged in, we can start by creating an empty database. We do that with create database postfix. Let's check that we have one created with show databases. As the database is created, we can create a user that has access to that database. Let's create this user with create user postfix at wildcard identified by and provide a password. With the user created, let's give this user some limited access to that database. The Postfix user only reads from the database, never writes, which is why we will provide that user only with a select attribute. The command is grant select on postfix dot asterisk to postfix add and the wildcard. To activate this access, we have to flush the privileges with flush privileges. Great. We have a database and a user. Now we need to populate the database with values so Postfix can actually use these tables to make sure only the people in these tables can send and receive emails. I will have 4 tables which I will walk through and describe what they are used for, by which option in Postfix, and the query used. The last table is exclusively used by Dovecot. We will create it here, but that table will not be used by Postfix. We will start to enter some information and test these tables using the config files we created for Postfix. The first table is the aliases table. This table is responsible to reroute emails that are addressed, for example, to root to an administrator inbox. There are a few defaults on an email server, such as root or postmaster. Emails addressed to one of these users would be forwarded to the email box of the administrator. In my case, that's obviously me. However, the aliases option in Postfix, which uses this table, is mostly concerned with forwarding traffic to local Linux users. I could omit this table, as we also will create a virtual aliases table, but hey, why not? Before we create that table, let's switch the databases with use postfix. Now that we switched our databases, we can create this table with the command create table. If not exists, aliases id int auto increment primary key alias with a variable character and 100, recipient also variable character 100, active boolean not null, and we have our first table created. show tables, we have our aliases table with the columns, show columns from aliases, ID, variable character, and tiny int and not null, auto increment, and our primary key. How is this table used? Let's imagine you have a postmaster email internally to your server. How do you want to submit any of the emails that are destined for this email address to a mailbox? You can create a virtual user, but you can also just create an alias in your database and reroute that email. That is what this aliases table does. Upon receiving the request to submit an email to that address, Postfix checks if there is an alias. The option in Postfix main.cf is aliases maps. Let's check that out quickly. Postfix main CF, and we'll take a look at alias maps. Here is right down here in line 427, you have the alias maps where this check would be executed. And the check itself, as we use a database, is used in postfix dbconfiles. We select the recipient from the aliases table where the alias is postfix, for example. Let's walk through an example. We are going to insert into aliases an alias, a recipient, and we want this recipient or this database entry to be active. So the values that we're entering are: an email is addressed to postmaster. The alias would be Manuel at localhost, and 1 for it's active. Need to spell this properly. Select all from the table aliases. That's better. Everything that's addressed to postmaster will be forwarded to the recipient, Manuel at localhost. We can do the same thing with root, for example. If an email is addressed to root, we want this email to be forwarded to a real email address or a real user, which in this case again is myself. Now we can select everything again, and we have two forwards. One is from postmaster to Manuel at localhost, one is from root to Manuel at localhost. You can also do forwards to from root to postmaster. This request would be executed as often as necessary to find an email inbox of a user. Great, let's empty our screen again. As table number 1 is created, table number 2 is the user map. This table is the most important one for my implementation of Postfix, as that list contains everything required to send emails from the email address to the mail relay to the user password required to submit the email over that relay. So let's create the table, and I will show you along an example. We create this table with create table if not exists user map ID int auto increment primary key ISP mail variable character 100. Not null this time, however. Local mail variable characters 100 as well, not null as well. Relay variable character 100. As you can see, I like to use this field quite a bit. Not null. Then we have the password, which is var binary 100. We'll get to that field and the data type in a second. Not null. And active boolean no, not null. Once created, let's take a look at the columns with show columns from user map. And as you can see, we have the ID, which is the primary key and auto increment, ISP mail, local mail, relay, password, var binary is the data type on this particular field, and the active is a tiny int. As I mentioned, this table is crucial, but it also contains some security features. As the list contains a password, which I do not want to leave unencrypted, this field specifically is of data type var binary. I will use the AES encrypt and decrypt function in SQL to encrypt or decrypt that password from this table. This table is used by 3 different queries. Let's take a look. Postfix, vim postfix dbconf files. So we have the virtual mailbox uses this table, as well as the sender dependent relay host maps uses this table, as well as the SMTP SASL password maps. Query 3 and Query 4 are directly relatable to the postfix option, but unfortunately I use the name virtual mailbox in Query 1, which does not immediately reveal which option in postfix uses that query. So I will open up 2 different files in parallel to highlight the connection. One file is the main.cf and the other is the deployment, as that will make more clear where this particular file and query is used. Let's open these 2 files with vim-o postfix deployment.yaml, and which will be open on the top, and postfix main.cf. If we scroll down all the way in the deployment to the script within the startup container, which replaces and activates out-commented options in the main.cf, we see the file virtual mailbox.cf is linked with the SMTP generic maps option in postfix. Let's now switch over to the bottom of the screen with Control W and find that option with /smtp generic, and we see the out-commented option, which will be activated by the script shown on the top at the startup of the container. This SMTP generic maps function from Postfix, which I use with the virtual mailbox.cf file, is responsible to translate the email address from Manuel at localhost to a real email address such as manuel@outlook.com. The challenge I have with that query is, depending on how many email addresses you summarize in one mailbox, will result in several matches for an email address. To avoid these several results, you have to highlight one email as the default. The sender-dependent relay host maps identifies the relay to be used for a particular email address from the table. There should be only one match, the relay to be used for that particular email address. we will take a look at the results once we have Postfix deployed. The SMTP SASL password maps query is the most difficult query. In it, we make sure to build the login string for the email relay we intend to use to send that email. Usually that consists of the email address and a password. However, you could also end up with an API key for that particular relay. So let's add some data into the table so we can see once Postfix is deployed how the results of these queries look like. Insert into user map. I want to add the ISP mail, local mail, the relay, a password, and of course active values. My ISP mail is followed by my local mail, which is Manuel at localhost. We have a relay, which is we're going to start with square brackets, mail dot, and then we do have the port that we need to add. If you have a port that you need to manage as well, then you have to enter the email relay as shown on your screen. Next is a password, and that one obviously I will not mention, but we also have to encrypt it. So we use the AES encrypt function. We're going to enter the password for the mail relay and follow up with a password for the decryption. For the encryption and decryption, you have to use the same password, obviously. And then we enter one for active, for an active entry. As my server did not want to be found, the connection was re-established. Now we can take a look. Select everything from the user map. From user map. As you can see, the password is encrypted through the AES function, and all the rest of the details is shown in clear text. As we have our second table created, let's now empty our screen and take a look at the table so far. Show tables. Alright, we want to try this again. Great, we have the aliases and the user map. Let us move on to the next table, the virtual aliases. This table will help Postfix to match email addresses to users on my virtual domain. Just as the alias table takes care to match emails to local users, this virtual table does the same for my virtual user setup. For me, that means I enter all addresses for which I want messages to be sent internally without ever leaving my server to that table. An example would be to forward everything that's addressed to Postmaster at localhost to Manuel at localhost. I would also avoid sending out emails that are addressed to my internally managed users. So I will use their addresses and link them to their localhost counterparts. Every time an email is addressed to one of these users, Postfix will identify that and internally hand this email off to the user's mailbox. So let's create the table with create table if not exists, virtual aliases. ID is integer and auto increment. Primary key, intended recipient is varchar 100, not null. Internal recipient is varchar as well 100, not null. And active is active boolean, not null. All right, the table is created. Let's take a look. Show tables. Perfect, here we go. So how does that look like and the table work? Let me add some data and we'll walk through it. Insert into virtual aliases. I want to add the intended RCPT. I want to add the internal recipient. And I want to add the active. The values are your email address, whatever that looks like. The internal recipient is me, Manuel, at localhost. And last but not least, 1. Select everything from virtual users. Aliases. Virtual aliases. So when you send an email and that email is addressed to the match found in the first column, the intended recipient, let's say Manuel at outlook.com, Postfix looks into that table and then forwards the email instead of sending it out, forwards it locally, internally to the server, to the inbox of the user Manuel at localhost. Postfix always executes the aliases and virtual aliases table matchings in case they are specified. As we are still in the deployment and main.cf files to our right, let's quickly take a look. At first, in the main CF on the bottom of the right screen, let's look for the virtual aliases entry with /virtual aliases pattern virtual alias. It's called virtual alias maps. We see the outcommented option in line 717. Switching over to the deployment on the top in line 135, we see the command that replaces the outcommented option virtual aliases maps and adds the database connection file. As this table is created, let's now empty our screen and get to the last table, the virtual users. Although this table is only required for Dovecot, I do not want to go back to the database later and will create the table now. We will still have to go back and enter the data, but at least we will not need to create the table at that point. Let's now create this table with create table. If not exists, virtual users. And we need the ID again. Integer auto increment primary key. We need the local mail, which is varchar 100, not null. We need the username, and we're gonna username varchar, and this one is only 50, which is enough, not null. The next part is the password again, and we have a var binary because we're going to use the AES encryption function again, and we're going to set this to 100. And last but not least, oh no, not null. We don't want to forget that. We must have a password. And last but not least, we have active, and that is a Boolean field, and also not null. Let's go through this again. ID, local mail, username, password, semicolon. Let us take a quick look now that this table is created with show tables. And we see our virtual users, and I would like to take a look at the columns as well. Show columns from virtual users, and we have all 5 columns created. As I mentioned, I will go through this table in detail in my next video, in which we discuss Dovecot and will enter data. The main reason is that we need to also generate a password that I need for the users to log into their mailboxes through Dovecot. At least the table is created and we can move on. As much as I wanted to omit this part of the implementation and not walk through the database, it is an important part of the application and should not be skipped. I know that took us quite some time, but keep in mind that the implementation of Postfix is a more complicated endeavor which needs a more thorough discussion. As we set up the database, it is time to deploy our Postfix. We will start by creating the namespace with kubectl create namespace mail server. kubectl get namespaces. Our mail server namespace is right there. As there are quite a few configuration maps, let's bring up the list on our right hand side, ls, and we see all the details that we need to deploy. On the left hand side, we will switch directories to our Postfix implementation folder, and we can start deploying our config maps. We will start by replicating our secret from the namespace Nextcloud. We can verify that the secret within Nextcloud is configured correctly by describing this object with kubectl describe secret Nextcloud cert tls -n Nextcloud. We see that the mail server namespace is allowed to pull the certificate, so we do that by deploying the empty TLS cert and TLS key through the postfix cert YAML with kubectl apply-f postfix cert.yaml. As usual, we get an error message, but if we describe the secret with kubectl describe secret tls secret -n mail server, we see that we have actually data in the previously empty secret. Perfect. Let's empty our screens, bring up the list from Postfix folder again. With the certificate deployed, let's move on to the next file, the create CF files. We deploy that with kubectl apply-f postfix create CFs YAML. Once deployed, let's verify kubectl get cm-n mail server. The init script is deployed. Perfect. And the next one is the db connection files. kubectl apply-f postfix dbcon. I'm also going to verify that deployment is complete. 13 pieces of data for the CF configs. Okay. Next one is the deployment, which we're going to do last, obviously. We need to have everything else in place. I will deploy the DH parameter files. kubectl apply-f postfix DH parameter files. That this time will not be a config map, but a secret. kubectl get secret -n mail server. DH parameters deployed. Perfect. Next is the main postfix main.cf, kubectl apply-f, postfix main.cf. Postfix, I called that one postfix. Probably should have called it differently, but that's fine. Next file would be the master.cf. We'll deploy that with kubectl apply-f postfix master. Okay, that one is easier to identify. Next we have a secret, which is the database secret for my deployment. So let's apply that file, kubectl apply-f apply-f postfix secret. Kubectl get secret -n mail server. The database secret, DH parameters, and TLS. All three are there. Perfect. Now the last two pieces that we need is the postfix service account and the service. I'll deploy the service account first. And once that's done, we're going to switch to our watch command, kubectl, to watch the deployment of the remainder of postfix -f postfix svc account YAML. That is the user that manages postfix in the namespace. The role and the role binding, as you can see, those are created. Let's now empty this screen, bring up the commands. So the last two files we have to deploy is the postfix service and the postfix deployment. And then we should see the postfix pods spinning up. In order to do that, to watch those spinning up, those pods, we will watch kubectl get all-n mail server. Okay. Kubectl apply-f postfix deploy YAML. Here we go. Alright, the pod's spinning up. That's good. The init container is starting. That's the preparation for a main deployment. The init container is complete. Now the final pod or the final container is initializing. Sweet, our first postfix instance is running. Second one is ready. And all three replicas are up and running. My server seems not to be the fastest today because the readiness state is still trying to catch up, but that is fine. At this point, we're going to do some verifications. I'm going to copy the address of the first pod here and just run kubectl logs only once 7th75-n mail server. We get the output from the main file or from the console, from the container. We see that there are a few readme only files, which is fine. The master.cf is a read-only file, which is fine. We don't want to change that in the container anyways. And then we see that postfix is up and running. As soon as you start connecting to this postfix instance, you will start seeing additional logs. Everything that basically happens will be logged out on the console, and you will see that detail on through that command that we just entered right here. We can do the same with the second pod, kubectl logs, here we go, dash n mail server, and we will get the same output. We can then also verify that our database connection files have been created. We do that with kubectl exec-it, and we're going to take pod number 2, dash n mail server dash dash ls etc postfix. We should see a few database connection files, which are, for example, aliases.cf was created, virtual alias, virtual mailbox sender dependent relay host maps, and SASL as password maps have been created as well. So that process worked out fine through our initialization container. Despite the fact that we have all the files created, how do we know that the container still works and that we can actually get the database connection once we actually need it? That is a very good question, and we'll take a look at that. The command we need within the container is postmap-q. Then you provide the username, which in our query is represented with the %s, and then you should get and then you add the connection file, and you will get a result. Let's do that with the virtual alias maps. So I'm going to kubectl exec-it. So we're going to execute within the container the following command: postmap-q. Then I provide my email address because I want to forward every email that comes in or every email that I'm trying to send to a certain email address, my email address, through my relay does not need to be forwarded to an external relay. I can just internally forward it right directly to my mailbox. So I provide my email address that I entered into the database, and I provide the MySQL file, which is under etc postfix, and it's called virtual alias map.cf. If everything works well, I should only get one result, which is my internal email inbox, to which this email would then be forwarded. We can do the same for all other CF files, but you can test it for yourself if you want to make sure. I recommend you do. Fantastic. With this test successfully completed, I will wrap up this video. What is working? We have a postfix deployment in place that is ready and able to receive emails and pass them on to a downstream service. As the inbox for users is not in place yet, these emails would be lost, so we will not send anything to Postfix yet. But what would work is sending emails through the mail relay that we have defined. What is next? In the next video, we will be setting up Dovecot, which will then be able to receive the emails and save them in the inbox of the users. We will also have to set up a synchronization for Dovecot, as the application is only capable of master-to-master synchronization for 2 nodes. As I will be setting up 3 replicas, we have to implement our own solution. Thank you so much for watching. I will see you in the next video.